Next thing we're going to do is take a look at simplifying rational expressions. Recall that a fraction in lowest terms is when the numerator and the denominator have no common factors other than 1 or -1. So what we're looking at basically is that we can take our numerator and denominator and factor them, and any factor that we have in common, we can split it and write it as a separate fraction. Well, anything divided by itself equals 1. And if it equals 1 and we're multiplying by 1, it doesn't change anything. If we look at a basic example with a fraction, 15 over 65, we can break these apart into factors of 3 times 5 and 13 times 5. And we see they have a common factor of 5. So we have 3 over 13 times 5 over 5. Well, since anything divided by itself equals 1, the 5 over 5 eliminates and simplifies, leaving us with just 3 over 13. The same idea can be applied to our rational expression. If we have x plus 2 squared over x squared minus 4, well, our numerator is just the binomial x plus 2 twice, while our denominator factors as a difference of squares. Recall that this is a special case factoring, which factors to be the sum and difference of the squares, or the square roots. And so here we see that we have these common factors. We have x plus 2, and then x plus 2 over x minus 2. Well, one matching set of x plus 2 will eliminate, leaving us with just x plus 2 over x minus 2. Now, this brings up an important point. The difference between a factor and a term. A lot of times people will think that this can be simplified further. They'll see the matching 2's and the matching x's and try to eliminate them. But we have to remember that we can only simplify common factors. Factors versus terms. Factors are multiplied, while terms are added. So when we look at x plus 2 and x minus 2, x and 2 are not being multiplied, they're being added together, which makes each of these terms, not factors. Same with x minus 2. Those are terms, not factors. So since none of these are being multiplied, they're not factors, meaning we cannot simplify them. That is as far as we can go. Understanding the difference between factors and terms is critical when making sure that you're properly simplifying rational expressions. So when we formalize our process, our first step is to completely factor our numerator and denominator. Now sometimes all we have is a GCF, sometimes it's already factored, but we always want to check to make sure that they are factored as much as possible, which aids in the simplifying process. Once it's factored, all we have to do is divide out the common factors that are in the numerator and the denominator. So when we look at our first example, we see that the numerator is essentially factored. We could break it apart into 2 times x, but that may not be necessary. The denominator, however, has 2 terms with a GCF of 2x squared. So we can factor out the greatest common factor, 2x squared, and we're left with 5x minus 1. Now notice we didn't simplify anything in the first step here, because while they both have 2x squared, this one is not being added to or multiplied by anything. It's being subtracted, making this a term. But once we factor out the GCF, now it is a factor. And since it's a factor, it can be simplified with this factor. And we can always assume that there's an additional factor of 1. It's being multiplied by 1. There's no addition or subtraction in the numerator. So since we have the common factors, we can go ahead and eliminate 2x squared, leaving us with 1 over 5x minus 1. Since there's no other factors in the denominator and the numerator is only a 1, this is as simplified as we can get. Now we have some trinomials that are a little bit longer. We can still factor them using our product and sum, but because we have the leading coefficient, remember there's an extra step involved with factor by grouping. So the first thing we'll do is we'll factor the numerator. For the numerator, we're looking for a product of A times C, which is 36, and a sum of 13. Well, that's going to be the numbers 9 and 4. Now recall that what we do now is we actually split our 13x squared, or I'm sorry, our 13x into the two terms based on the numbers that we found. Now that we have 4 terms, we can factor by grouping, leaving us with 9x plus 4 and x plus 1. Now let's go ahead and factor the denominator. So with 8x squared plus x minus 7, again we want a product of A times C, which in this case is negative 56, and a sum of B, which is 1. That's going to be the numbers 8 and negative 7. So we'll split our middle term into 8x minus 7x, and then we can factor by grouping, leaving us with 8x minus 7 and x plus 1 as our denominator. Now that we have them both factored, we look and we see there is a common factor of x plus 1, so we can eliminate those, leaving us with 9x plus 4 over 8x minus 7. We take a look at C. Our numerator can't be factored any further. We just have 2 terms, there's no common factor, it's linear, we can't factor it. Same with the denominator. So I don't really see any common factors. However, note that I'm adding in my numerator. 2 plus x is the same as x plus 2. Commutative property of addition. We can rearrange these 2 terms. The order of addition doesn't matter. Well, now I look and I see that I have x plus 2 over x plus 2. When I divide something by itself, it simply equals 1. Now D is very similar, but the difference here is we have subtraction, and subtraction is not commutative. We can rearrange if we rewrite this as plus negative x, and rewrite it as negative x plus 2 over x minus 2, and we're getting closer to something that we can use to simplify. The terms match up, but the signs are different. Well, something that we can do instead is we can actually factor out a negative 1. Negative 1 is always a valid factor. So if we factor out negative 1, we're left with x minus 2 in the numerator, which matches up with the x minus 2 in the denominator. When we simplify, now we're left with negative 1. Factoring E, we'll start with greatest common factor. In the numerator, it's 2, leaving us with 9 minus x squared. The denominator, we have a product of negative 3 and a sum of negative 2, giving us x minus 3 and x plus 1. We don't have any common factors, so possibly there's something else that can be factored more. And you would be correct, we have a difference of squares in the numerator. So it factors out as 3 minus x and 3 plus x. We're getting closer to having a common factor, but not quite. Well, just like with the previous example, we have opposites here. So if we take a negative 1 and factor it out, then we get x minus 3, commutative property of addition for x plus 3. Now we have these matching factors in the numerator and denominator. X minus 3 eliminates, and we simplify to negative 2, x plus 3 over x plus 1. As a note, always want to leave your numerator and denominator as factored as possible. Even if you still have some multiplication left over, you do not need to distribute it. Leave it completely factored. F is interesting because we have this binomial, but we notice it's a sum. So we can't have a sum of squares, but notice instead we do have a sum of cubes. Sum of cubes again follows the pattern of a plus b, a squared minus ab plus b squared when we factor. So x to the third plus 8, the cube root of both of those is going to be x plus 2. We square the first term, we multiply the two terms, and we square the last term. Then since our denominator is addition, we can rewrite this as x plus 2 using commutative property, and we have our matching factors. So our simplification is just the polynomial x squared minus 2x plus 4. Lastly, we start with a GCF, and then our denominator can be factored by grouping. So we factor out a y squared, leaving us with y minus 5. We factor out a 1, leaving us with y minus 5. So we have y squared plus 1 and y minus 5. We have the matching factors of y squared plus 1, leaving us with 2 over y minus 5.